Good morning, everyone. It's 11 a.m. here in France, and I want to welcome you to this webinar that we have organized to launch the new booklet that we have prepared, a new free booklet that we have prepared over the last year, I would say, together with my friends and colleague of the Euro FM group within the EPMA, and dedicated to the functional materials sector, Introduction to Functional Materials. This booklet has been prepared with a large collaboration, and we'll discuss it today. And it will be explained to you as per the agenda that you should see on the screen now by my colleagues Sebastian Hein from Fraunhofer IFAM, who is already here in the meeting, and who is also a co-chair of the Euro FM group within our association, and Martin Bram from Forschungszentrum Jülich, who has been the real engine behind the production of this booklet, I would say. I will also give you a short presentation of what we do in this sectoral group about functional materials at EPMA. And then I will leave the floor mostly to you, attendees, to ask questions to all the experts that are present here, not only the two that are going to talk, but also the other ones who contributed to the booklet are also present. Many of them, all of them, unfortunately, were available. But you can also address questions to them, and we will distribute them later. And yes, and also discuss about the possible improvements of this booklet. We will have a new edition in the future, so we could add sectors, we could add details, and change if you see that there are some things that have to be changed. I also want to show you how international this event is. We are a European association, but actually the registration here shows that the interest about this topic is well spread around the world. Yes, we have a lot of people from Europe, especially from Germany, as you can see here, but also from India, Iran, so very distant from us, other countries in Europe, of course, Turkey, Japan, and USA. So I welcome all the people from distant countries, especially those that have problems with the time zones, to be here at this time in the day. Thank you for being here. So having said this, I also would like to show you what will happen after this meeting. We will have a session that will be a chat. So it will be possible to join it. I want to show you how to do it. And actually, you should have received, as you are here, I will show you in a second. Yes, let me share this other screen. Yes, you should all have received a PDF file showing how the thing can be done. There is a networking chat room which is hosted by a website which is called wonder.me. And in this file, you have the instructions on how to join. So there is a link. And when you click on the link or copy paste in your browser, it just takes you to this room. You will have to answer some questions, actually. So for instance, accept the cookies. And then you will have to request browser permissions to use the camera and the microphone. So you have to allow this. After having done this, you will be, yes. Can I say yes? Okay, you have to enter the password, and it's also in the file. It is intro FM. I think you can see it. Yes, next. So you join, you can take a snapshot of yourself that will be seen on the and put your name. Please do not use just nicknames, because we don't know who you are then. And then yes, then you're actually in. You can see you are in the room. You can move, and you have an avatar. There are some explanations. If you click here and there, you can move in the room and meet other avatars. When you do it, then you will have a video chat open, and you will be able to talk to the people who are close to you. So I hope you can join this after the meeting to have better networking among us, and actually be able to talk to the speakers and to the other fellow attendees later more freely. Okay, having said this, I think we can pass the floor to the first speakers of today, which are Sebastian and Martin. Thanks for being here, Sebastian and Martin. And yes, the floor is yours. Do you want me to share the booklet?
Yeah, so this would be nice if you start with sharing the booklet.
I'll do it in a second. Let me bring it up and I'll show it. Okay, where is it? Yes. So in the meantime, maybe if you want to introduce yourselves while I share.
Yeah, okay, so I'll start. Sorry,
yeah,
Martin. Yeah, Sebastian Hein. Bruno already introduced us nicely, I guess. So I'm working at Fraunhofer IFAM in Germany, in Bremen. And I'm also co-chair of the sectoral group of functional materials, together with Peter Kjelstien, who's not attending today. At least I haven't seen him on the list. Yeah, so I think main work of this booklet has been done by Martin. So I'll just hand over to him and let him start a little, and I'll just jump in if I think I want to add some things here and there. So please, Martin.
Okay, thank you very much. So my name is Martin Brahm. I'm from the Forschungszentrum in Jülich. I'm a material scientist, and in our institute we are working on a lot of functional materials. Most of them are ceramic materials, but we also have some powder metallurgical applications for these functional materials. And our topic at the institute are materials for batteries, fuel cell, electrolysis. So I think it's one of the most important topics of research and application in the next years. And so we try to include this kind of information in the booklet. So first of all, I want to thank all of the people who are attending today. So I'm really surprised that we have so many attendees and from all over the world, which is also quite nice. And I think so maybe I can give a few words to the motivation to make this booklet. So you know that on the European conference, we always had the topic functional materials, and often this topic was not really structured. So it was always not completely clear what it means, functional materials. And so in 2018, Peter Kjelstien started to motivate an own sectoral group on this functional materials. So the big difference of this functional materials to the other sectoral groups is that we really mostly focus on the application, where other functional groups mostly focus on the processing, like additive manufacturing, hot isostatic pressing, and some things like that. And so the problem of making this kind of booklet is that first we have to think about how to make these kind of widespread topics, which are related to the functional materials, how they can be combined in a booklet, which makes more or less sense and have a red line that you can really get information that you need for this kind of topic. And so now in a discussion with Sebastian, so we now make a first proposal how to structure the booklet, and based on this discussion, now we have the first edition. So we filled all of the gaps with text, and currently most of this is really written as a text, so not not as bullet points like in other books of sectoral groups. And this is one of the first things that we can also discuss in the next hour. If you like the way how it is presented currently, or if you have some other ideas how it can be improved further. So this is maybe something, a short introduction. So and then maybe we can go to the second chapter about the motivation and challenges of functional material itself. So Bruno, can you a little bit scroll through the booklet? Yes. So here you can see this the overview, the content. So this is more or less the structure that we decided with Sebastian for the booklet. And so you can see the most topics that we identified that should be included in the booklet. So we have also a longer chapter about powder metallurgical processing techniques. So there is maybe the first discussion about if this chapter, which is written really like a textbook, if it's really fits to this kind of booklets, if it's too much information, if all of this information is required. And so this would be one of the first things that we might discuss. So maybe all of you already have a look on this book, and this would be interesting to get a response for this chapter 3. If this chapter is too long written in the way as it is, so maybe we can here already start some discussion about this chapter.
Yeah, I think we wanted to really at least hint at all the aspects that somehow touch the functionality of the materials. And of course, we have to look at the whole process chain of various processes that exist in the PM world, and this makes it also a little more widespread than more focused booklets, as Martin said before. So we thought we start by putting everything together, so not to leave out anything that may be very vital to the topic, but yeah, as you said, Martin, perhaps it is too much. I mean, you don't have to read it if you're not interested, but still it would be just really great to get some feedback on this. I mean, there's quite some work that has gone into this part, of course. And yeah, I mean, we can always have it, at least in the digital version. It's not a problem to have too many pages. Of course, in a print version, it might be a different thing. So this is also a point that perhaps is good to have a small feedback about, like if you would at all have a printed version that you would like to receive on, for example, Euro PMs or World PMs and other occasions like seminars from the EPMA, or if this is completely sufficient as in a digital form, and if this then can be a little more extensive than a printed version, for example. So just a small addition from my side. I think the main part is chapter 4 in this booklet, actually. So I don't know, Martin, perhaps you want to continue?
So you know that in this European conference, there is always this kind of functional materials. There was also a restructuring of these topics in the conference. And these kind of structures that we make in the booklet might be also helpful to structure the functional materials in future in a better way. And maybe we can also form some subgroups. There are some topics which are of really high interest, which up to now not very intensively are discussed in the conferences. For example, to my opinion, the magnetic materials is something which has a really bright future perspective. There are a lot of topics like, for example, how to handle the problem with raw materials, how to improve recycling, how to improve the functionality of these materials. And this might be a possibility. For example, it will be also included in a special interest seminar on the conference, but there might be also a possibility to even bring some experts on the topic together by our sectoral group on functional materials, but also maybe by attending to the conference. Then other very important topics which are also not very deeply discussed so far in the powder metallurgy community as is energy conversion materials and also energy storage materials, and over there's a lot of powder metallurgical applications already today. So some of them are really on the market, but most of them are not really known, and it might be also a possibility to find new applications for powder metallurgy. Then there are other topics like high temperature materials or materials with functional porosity, which are already established on the market. So there is not too much new currently, but nevertheless they are really important, and some of the companies are really focused on these kind of topics. And then there are some other topics like biomaterials or friction materials, which are so also of interest. And so one of the questions that we also have to the audience, do you think that we covered mostly all of the topics that you would be related to the functional materials, or should be any other topic covered? So one is missed because we don't find someone who really write a chapter, is for example the topic contact materials, which will be also an important topic for the future of energy supply worldwide. So maybe this is something to this chapter 4, and then if we already talk about the content, so where we really need further input is the chapter 5, where we present some case studies, and if there is maybe some people from companies who would be interested to present their applications or products in this chapter 5 on the case studies, this would be very nice if we can include some more application. Currently, this kind of case studies is very inhomogeneous. It's mostly a collection of case studies from other sectoral groups. And so it would be nice. So today we have a lot of people from different disciplines and different, probably also industry. And this could be of really interest if you have ideas to bring your product also in this booklet. So we would be very interested if you can support us with this. So this is now more or less a very rough overview about the content of the booklet. And now we can a little bit start to discuss about also the content. So one thing what I also want to ask is, currently it's mostly focused on powder metallurgy, but a lot of topics also include ceramic materials. And it was always a discussion in this EPMA if ceramics should be included in this kind of seminars or in this kind of conferences. But if you really talk about functional materials, often the function is just given if you make a good combination of metallic and ceramic materials. And so it might be helpful even to include some ceramic applications, ceramic materials for this kind of, but I'm not sure if it makes sense, so it would be really further enlarge the size of the booklet. I'm not sure if it's of interest or not. So for example, you can also talk about the materials for solid oxide fuel cells or for electrolysis. I'm not completely sure about this, so maybe you can also comment on this.
Do you want to browse through the booklet now?
So in principle, I a little bit introduced the booklet, and so maybe we can a little bit more start a discussion with this overview of the chapters that we have. I think nobody's really able now to read chapters, but so maybe we can already start a little bit the discussion about the topic.
I don't know, Bruno, did you have some other points you wanted to share before we go into this meeting?
Yes, before the actual discussion, I see already some questions and comments in the chat, and of course everyone will be able to do it. But I want to show something on my side before we start. So if we think we are ready to go on, maybe I'll do my presentation and then we pass to the discussion. All right?
Yes, that would be great.
So let me share my presentation again. Okay, so I have to find it. Yes. Then slideshow back. Okay. Just a second yet. Right. So I was here. Okay. So yeah, I showed you about the networking. I just wanted to mention another thing that I forgot during my introduction is that the webinar is recorded. And we will have the video on the EPMA website. For everyone who actually missed the seminar, the webinar, it will be possible. They have to be EPMA members, though. It will be possible to go to the website and watch it again. We could have also further comments from them later, and we will distribute it to the relevant people. Okay, so about EPMA EURFM Sectora Group, I will take a few minutes to explain what we do. Just a few words about EPMA. EPMA is the European Association for Powder Metallurgy. We have an history of 32 years now. We started in 1989, and we work to promote, develop, and represent the PM industry of Europe at any level when it's needed. And we're made up by our members, actually. So there is a team working for you at EPMA. This is the team. We cover quite a number of processes, and starting from metal powders, production and characterization, whatever, and the shaping of the powders into parts, and also in some cases we have end users who are actually using these parts. And we also have all the equipment people or companies that support the production of metal powdered parts, and all the research which is behind this. We even have a group dedicated to that. Because in fact, most of activity of the groups happens in sectoral groups, which have been developed over the years. Whenever there were needs for representing a certain sector and having networking activities, projects, research projects. So every time we have all these changes in the powder metallurgy industry, we try to represent them in new sectoral groups, and we do meetings, we do statistics and surveys on the sector. We organize seminars, and this is an example. We create publications, and we have an example here today, and we foster research and innovation. So we have this image of the powder metallurgy tree, which grows from the powders, with the roots in the powders, and develops branches in the different sectors. And EURFM is a sectoral group which was introduced in 2018. And after some successful events, and it's actually covering all this sector of some, well, let's say, strange materials or specific materials which are not just used for, say, mechanical properties or but also for physical properties, for instance, chemical properties or other properties. And yes, we have had seminars. You can see the last seminars that have been held in person. Really, the last one was in Bremen in 2019. And we have this booklet now, which is going to be a good tool for promotion of this sector. We don't have statistics, but we might be working on it. It's a bit wide spectrum of activities, so it's difficult to imagine statistics for the whole sector, probably for subsectors. And the group is chaired by Sebastian, who is here today, and Peter Kirsten, who has been mentioned before. And there is a steering committee. Martin is in the steering committee, and that's more or less the government of the group, where we decide what has to be done over the year to achieve interest in the sector. And for instance, in 2020, we organized at the virtual Congress European 2020, 2 special interest seminars, plus actually one who was in the metal injection molding trend, but it was about powder injection molding of functional materials, and sessions, technical sessions on functional materials. We had already a free webinar last year on soft magnetic composites in October. We organized a virtual seminar last year on applications of functional materials in November, who had a good success. And we started working on the booklet, which is now ready. We also had a sectorial group meeting in December, and you can see some of the pictures there reflecting these activities. In 2021, we actually have this booklet and this webinar. Next week, in 10 days, I would say, we have the FM seminar. We'll go back to it, functional materials for energy. Then we will have activity in the Congress, which is again a virtual Congress this year. We will have 2 special interest seminars on advances and challenges in hard magnets, and one on functional materials for thermal management, and technical sessions, of course. We will have again a virtual open meeting, yes, there is an activity which is a discussion group on soft magnetic composites, which is a special topic. This has been postponed to when the COVID will be over, so that we will be able to run this in person rather than virtually. About the booklet, we already have been talking about this. We hope it will be a really useful tool for promotion of the sector. We are looking forward to maybe a second edition, and this is also why we have thought about this webinar, to collect ideas about this second edition. It will not be tomorrow, it will be probably in 1 year or even 2023. But yes, we want to have a second edition, of course. All other booklets are usually updated, and this was the first one, so surely there will be good ideas to improve it. And I hope you all downloaded it. I can say that we have reached more than 230 downloads today, so it's going well. And yes, the seminar, I want to invite you all to the seminar. You still have time to register. This is not a free webinar, it is a paid seminar. You have to register and pay a fee, but it's a very interesting program. And you can see some of the topics there. Here are the speakers that will be there, the companies and universities and projects involved in the program. I think it will be a very interesting seminar, and we are collecting registration until next week. So please think about that if you are available. It will be online, of course, so no need to travel everything. It will be an interesting event. So this is more or less what I wanted to show you today. Of course, I'm ready for questions later, but I think most of the discussion now has to be on the booklet. And so with this, I would stop sharing again and go back to you, to the audience. I already have seen some questions in the chat, so maybe we can start from there. And of course, anytime you want to ask a question, you can raise your hand or write again in the chat, and we will come to you. You can also pose the question yourself if you open your microphone and maybe even your camera if you want to ask the question. So let me go to the chat and see what we have already there. So I'm starting from Monsieur Honard, I think. I don't know if you want to open your microphone and just give your comment live. It would be good for the others, I think, if you're available. Otherwise, I will read it. Hello? I think he's not in the meeting at the moment. So his comment was actually I can read it, everyone can read it, but we develop the process which works and as customers to make functional parts with 100% density for various metals, steel, nickel alloys, titanium alloys, and various applications including soft magnetism. This process is not in your list. How can we proceed? I think we have to discuss this, but in principle we can include it.
So from my side, I think this would fit to the chapter 3. And currently in chapter 3, we have small text block about processes which fits to the functional materials. So if you want to write a short text block about your process, then it can be included. So there might be also a possibility to include a small sketch if it's a new powder metallurgical process. Then we can try to include it. You can see how long these kind of text block about the different processes are. I think we should not make it much longer because then this chapter 3 will become much too long. So I think, but if you have a process, and there might be also a possibility to give a reference like a citation or something that can be included in the booklet.
Or potentially a case study to refer to.
Yeah.
That would also be great in this case.
Yeah. Right. Then there were other comments. Let me go back to the chat again. Yes, from Bram Neering. I don't know, Bram, do you want to say something? Yes. Hello.
Yeah,
Hello.
sure. Thank you for organizing this meeting. And I would like to thank EPMA for actually making these booklets publicly available. They have actually been in the past, when I was still in academia, one of the first sources I gave to students when they were interested in a topic on powder metallurgy or additive manufacturing. I first let them read the booklets as an introduction. So this is not really a question, it's more a comment. We are working on technology to do selective powder deposition, which can also be done in dyes. We've presented some stuff on the EPMA conference in 2020, on the European conference. And we are looking on developing this technology also to make functional materials via standardized powder, typically present sinter approaches, but it should also theory work with pressureless sintering. So I know in academia that some people have developed functional materials by just sequentially filling dyes. We are trying to do the same, but in a more controlled manner, and also have the capability in XY.
So do you want to include something in the booklet? So, or
I think our technology might be a little bit too early to include. We're just reaching out to the first research institutes now, participating in some projects to generate some functional materials. Once we've shown sufficiently what we can do with it, it might be something for the future, but not immediately.
Yeah.
We'd be more than happy to present stuff in conferences first.
yes.
Before it, I think these booklets are more towards a real industrial practices, applications that are already out in the market. We might be a little bit too low TRL to put in there.
Okay, thank you.
Anyway, the second edition will not be, as I said, tomorrow morning, so there is time for thinking about what to add, and maybe if something has to be developed yet, it can be ready for the second edition.
Mm-hmm.
We hope so.
Yeah. So any other? That was what we had in the chat yet. If there is any other question and comment, please just raise your hand or just open your microphone. Maybe it's easier if no one is really rushing to ask. On my side, maybe I can add something. You know, during the production of the booklet, we were very worried about the length of it, and tried a little bit to make it more concise, if we can if it was possible. And well, in the end, we didn't. We didn't do too much, but maybe it deserves a large effort like this one, because there are so many different families of materials, and also the technologies to produce them are sometimes specific. So it's probably difficult to make it much shorter. And that's why we had a lot of difficulties in understanding how to shorten it, because it's probably really difficult. And as you see, there might be also additions. So I think we will have even a lot longer one, which will not make us very happy when we will have to print it, but it might be a very good thing. Maybe also for people to bring it back on the plane, coming back from the congresses, if they want to have the printed version. But yes, I mean, if we're talking about the history of universe, you probably need to have a large book, right? I don't know if there are other opinions. If the people have downloaded the booklet and have seen it, what do they think? Are there paths that can be longer, shorter, missing things, as already Martin mentioned? There are some paths that we know are missing. So do you see any improvement on that? I don't know. Anyone? Or Jacqueline? Yes.
Yes. I haven't got my camera on at the moment. I hope that's all right.
No
I find it's an improvement, because when one is relatively new to the field, if one comes from another field, let's say energy technologies, and one starts off in the field of powder metallurgy, I find it very helpful during the congresses if one can have an overview of what the separate sections represent. So I find this new definition of functional materials and the definition of what is meant with energy conversion materials, or what is meant with energy storage materials, I find it very helpful, actually. Also, let's say at future conferences, that when you decide, okay, which session do I want to go to, which things interest me, because the field is so large and is so detailed, I find this definition of the functional materials quite helpful. Because we at CREMA come from the side of the plant technology. Then there's the side of the powder specialists. Then there's the side of the people dealing with actual tools. I mean, I'm not telling you anything you don't know, but it's such a huge field that I actually find this structure helpful. Yeah, I just thought I'd give you that feedback. I don't think it's too long.
Okay, thank you. That's a very nice feedback you gave us. So, and also if you think in the future about perhaps some further topics that we may include, always feel free to reach out to us. I guess it's not difficult to find our contacts if you don't have them already. So, or
come to us and we will distribute. Yes, and that's also covering a comment from Mr. Ostolaza that well, he complains he's not been able to finish it yet, so he cannot comment too much. But yes, there is a way to send feedback from now on. You just can send something to me or to Sebastian and Martin, and we will analyze that and get back to you in case. Absolutely. That's valid for everyone. I hope that we can have some more comments from our friends here. Maybe the ones who contributed to the booklet are also here in the audience. They might want to say something. I'm just browsing through the names. So, for instance, there are many people who contributed that are here in in the audience. And actually, if you go to the last pages of the booklet, there is also a list of all the people who contributed. It's quite a long list.
Well, I just activated my camera. I hope you can see me.
Yeah, hello, Stephen. Yes, yes, you're one of them.
Yeah, I did the hard materials bit, which is a teaser for the hard materials booklet, which should be coming in the next few months.
Let's say that.
I'd just like to tell you that watch this space. We will actually be launching that sometime in the summer. But just a point, actually, going back to what Bram Neiring said, it would be perhaps good to have a section on, if you like, future trends, future technologies, the low TRLs, what is coming, what do we expect to see in 5 years or 10 years from now?
So do you have an idea how we can get this kind of information from different people? So because we are not involved in every topic, so we have an overview, but I don't have, for example, contact to hard material people, and I don't know the trends in this field. So I can write something about the fuel cells or the electrolysis cells, which is more my topic. And so how can it be organized? Do you have an idea?
Yeah, it's a good question. No, I mean, I guess those of you working in the multiple fields of functional materials are keeping an eye on the literature, seeing what's happened and publishing, and maybe you know who the key names of key people are, the key contacts in some of these areas, that you would either contact them directly or just do, you know, as you would in your own field, a sort of a summary and assessment of the technology for your own benefit, which you could perhaps adapt to this. As Bram says, people are presenting at conferences, and sometimes in journals, for example, there are summaries made of sectoral presentations. So sometimes the hard materials one is summarized in 5 or 6 pages by, let's say, David Whittaker, for example, and so maybe there's this you can approach those people that as a job do that, reporting on the conferences, reporting on technology trends. But there's no clear answer to that. I don't have the answer. It's a function of time. I mean, that's the one thing that we don't have that much of, unfortunately. We're reliant on other people doing it as well. Okay. And in terms of the hard materials, I don't think it's necessary for you to put anything about the trends of hard materials into the functional materials booklet. We will hopefully do that ourselves.
So, yes, for sure.
Yes. Yeah. Good. I would also ask as I said, the others who actually contributed to the booklet to say their opinion. I don't know. I can go in order if you want. I have the list here. I don't know. For instance, Eleonora Bettini, who is here. Can you say something about what is your feeling about your path, maybe, or what you see in the booklet? Hello, Eleonora. Yes, we hear you. Yes. We hear you. Yes, okay.
Thank you for inviting me for today's meeting then also. About the part that I wrote, like it's about the high temperature materials, and basically I wrote mostly about nickel-based superalloys. What I was thinking, like for a future booklet, I was thinking also like about maybe like the difference because in powder metallurgy, so then you can compact the powder in different ways, and actually we did not go into much details like in this version, but for example also the properties of these high temperature materials, like if one compact them either like with HIP or like with laser powder bed fusion, or also binder jet. So these are all new techniques that actually are developing very fast lately. So maybe comparing also the properties and what is the benefit of using one technique compared to another one, I mean, specifically for this type of materials. Would that be of any interest?
Yeah, I think there is something in chapter 3, probably general.
But I was thinking like specifically for these high temperature materials.
Yeah. I think it might be of interest to make it maybe in form of a table which can be easily added to this chapter. So I'm not writing too much. And there I have the question, now, do you think that these processes which are shown in chapter 3 are sufficiently described to really understand later in chapter 4 what it means if in the table is talk about HIP or additive manufacturing of superalloys? Or do you think that it must be more or better explained what is the background of the different techniques? Because this would be then enlarged again chapter 3, which is probably not the optimum for future booklets.
I was thinking also like, but maybe I don't know if it becomes too specific, but there are specific requirements also for example, high temperature materials. I mean, due to standards and maybe like, for example, like porosity or like, and then mechanical properties related to also the porosity, but at the same time, maybe like for some application, it's maybe enough with a binder jet technique, but that is still like in the beginning also of the development of this type of materials with binder jet techniques. Yeah, now I am not looked too much in details about the chapter 3, like in that, but I can come back with some comments about that too. But I was thinking like, yeah.
So I think it may be actually also beneficial in the subchapter of the materials, because then I mean, you show how probably how these processes influence microstructures, porosities, and stuff. So this would actually build on chapter 3. So perhaps if the base processes are roughly described there, I mean, it doesn't have the, you know, we're not approaching to have a textbook that covers everything in detail. No. So I think perhaps having a very basic description of the processes in chapter 3 is good. Perhaps if there are specific processes that you want to show, if they're not described yet, then we can add those in a short paragraph. I wouldn't go too detailed there, but then to have this the basis for this comparison in the material specific chapter, I think that would suffice. As I said, as it's not a textbook in the end, but just to get an overview about some goings on in the specific field. So perhaps that would be a good approach for the second edition to have this detailed a little more for the high temperature materials. So this would be great if we could work on this for the second version.
Yeah. Okay. Maybe if we continue in my list, is there Moritz Stolpe available to comment as well? Sure. Hello, Moritz.
Can you see me? Okay, yes, good. Okay.
Not yet. We see you very black. Oh, black? So he's probably coming.
No, you should see me now.
Yeah, now you see. Yeah,
okay. Yeah, actually, you should see a lot of green. Actually, I was.
Yes. No, it's good.
Okay, good.
You're going green.
Apparently, the background I've chosen didn't work that well, so now you have to live with the green screen behind me. Yeah, so yeah, I'm very happy to be here today, and I actually contributed only to a smaller chapter. In chapter 4, and about bulk metallic glasses or additive manufacturing or powder metallurgy of bulk metallic glasses, and compared to some other let's say topics or materials, this is relatively new and it's a very recent development. It happened over the last 5 years in industry. And so I started in 2016 at the Reus, was working on these materials by selective laser melting or powder bed fusion, laser-based powder bed fusion. And a lot of things have happened since then. And just yesterday, for example, there was a release on a watch that was from a Swedish company. You might have seen this on LinkedIn, but you can check its name. It's Oscar Pascal. That's something which was produced by additive manufacturing. And I expect some more real applications coming soon. I mean, it's always a difficult thing to announce these things before the company wants it to be announced. So cannot talk too much about it, but there should be some more applications coming soon for these materials. And so in this chapter, actually, it's a very short chapter, and it just shows a few possible examples which are not really. So the question is it really functional if you show a guitar bridge, right? something like that. And so that's more or less like I would say is for music instruments you could say functional due to the, but it's not necessarily to the material properties partly, but also due to the design that you can create with additive manufacturing that haven't been able to create earlier. And there are also other companies working in this field, and this is, I think, emerging. And so for the next edition, I think we could maybe also involve these companies and ask them to contribute to really show what's going on there. I mean, it's as I said, it's a new field, but it's emerging, and so hopefully in the next edition there's more to report.
Good.
Yeah. Thanks. Perhaps a case study on a watch case.
Well, they're really nice, and I don't know the price, but probably I can't afford them. No, there are also other applications, like, I mean, for example, XMet is a company that is working on additive manufacturing of bulk metallic glasses, and they are focusing on soft magnetic material, iron-based bulk metallic glasses for stator cores and for electric motors and so on. And that's rather, let's say, a real functional material application compared to a watch, but you have to start with these things and then move to the next step, I guess. And there are also some US companies that are working on 3D printing of BMGs, more like in the gears or transmission section, and also some other like medical could there was recently an announcement from Heraeus, a case study on medical components. It's still in a development stage. I would say it's a larger a research program in Austria with University of Vienna and some other involved, and they are exploring these applications in the medical field for 3D printed bulk metallic glass alloys. So just to comment on this, so there is more than in the book, so maybe we can
hopefully.
By the way, XMet will be talking in the seminar in 10 days. So
that's true. So
advertisement.
Okay.
Maybe I can go through the list again and then go to Bernd Grieb, if he's there. Bernd, hard magnets are a big part of this big family. Are you there, Bernd? He was there.
I'm here.
Yes, hello.
Nice to see you.
Nice to see you too.
Well,
yes.
The main target I did see in this task was to reduce it. It is to make a very condensed form, permanent magnets. You can write books, and people did, of course. Therefore, it's very easy to increase the volume, to blow it up. There are no new materials really in the last years. It's going to be more popular, looking at the applications, of course, looking at wind power, looking at automotive. There are many cases which can be shown. Therefore, maybe I get some reflection from your side. If there is something special you are interested in, it would be easy to write a small article about. In the moment, I really tried to make it as condensed as possible. If people are interested in special materials, they find the information all over the internet, which is easy. But if you want to see a highlight or something, I can look for, sure.
So it would be nice if you can look for a case study or two. So where, for example, wind energy or for e-mobility, where the magnets are. So because nobody has a real feeling how the magnets look like in a wind turbine.
Well, yeah, in a wind turbine, I just got a big presentation from Siemens showing the newest version, which is in the range of 14 megawatt.
So
which is
how many tons?
Really, that's
is the magnet
power plant itself, and just the rotor has a diameter of 250 meters. It's going really to be something very special. Therefore, these highlights, of course, I would like to introduce, and if there is more space, I will do it. Yeah.
So I think with case studies we can directly talk about. So a case study, you can write a few sentences and show the size and the weight of the part, and this would be definitely of interest. If you have 2 or 3 case studies for the magnets, this would be really interesting. So currently it's not much available.
Yeah.
Thank you.
You're welcome. Yeah.
I actually see Yoko has the hand raised. Did you want to say something, Yoko? Hello, she's frozen.
Can you hear me or?
Now, yes, we hear you.
It's okay. No, it's okay.
Yes.
Okay, I have some comments about bulk metallic metals.
Oh, yes, Moritz. Before
because I see this has a very good potential for the future, especially for the soft magnetic materials, for the energy problems. But in fact, the problem is the cost. Starting from the powder production, it is very, very difficult. Therefore, I see the potential, but maybe it might be interesting to make a future discussion together with all kinds of industries, from the powder production to the also the consolidations. This is one point, yeah.
No, it's right. I mean, it's still so the quantities that are produced for these for the materials that can be printed are relatively small. So and not necessarily the metallic glass alloys that are currently present in this market can be used and directly transferred and are also the best in terms of their let's say printability or the property that are needed for AM. So yeah, that's usually leads to a relatively high price of raw material and feedstock material, but it's a little bit the chicken and the egg problem, I would say. And I think it's what you proposed is actually the key to solve this. It means that the powder manufacturers or the material manufacturers and the people processing the powders and also the end users need to sit on a single table and have a discussion and develop this together, because if you do not think about the scale up and the feedstock production, then obviously this will probably always stay in a niche, and since it's very high cost in the end.
Yes, I fully agree with you, and so we should make some group from the different industries to make a project.
Yeah, I mean, so one last comment. So the glass forming ability that is actually of these materials that are used in when they do the melt spinning of the thin foil, and then they stack these foils to produce transformator cores. So they are rather marginal glass formers. So they don't have a very good glass forming ability. Sometimes they don't even have a good thermal stability, and all that is actually a little bit more challenging when it comes, for example, to 3D printing via powder bed technologies. And so there must be some further development in this direction to really bring this to a successful commercial level.
Yeah, I see a raised hand again. Mr. Ostolaza, do you want to say something?
Yes, I wanted to make a remark. I have gone through the superalloy chapter, right? I'm a ex-PM guy, okay, who has worked for a while in the aerospace industry. And to going into the details of that chapter, I think that it doesn't very much fit with the functional materials at all. I think that it is about structural usage of superalloys, even if you may be using additive manufacture. But to me, it doesn't totally fit. I don't know whether you agree or not.
Well, we can read it again and see if
because
it can be improved. Yes.
No, I think what I'm saying is that functional materials to me, okay, is anything or mostly and nothing related with the structural properties, okay? But all the references and even the cases which have been shown there, okay, are very much, let's say, classical in the sense that we are referring to the usage of superalloys for structural applications as such, okay? So maybe I can help you, okay, rewriting it or maybe giving a different insight if needed, okay?
Yes, gladly.
Can you give an example which you have for function of superalloys, which is a typical function material made of a superalloy?
Well, superalloys are mainly used due to the high resistance to creep or high strength at elevated temperatures, right? I don't know, maybe I'm wrong, and that was very interested in, okay, whether superalloys can also be used, okay, for, let's say, for electrical applications, because of the magnetic properties or any others, right? So that maybe I can dig in, okay? I've been doing some work on those grounds, right? And maybe I can help, okay?
I think in our view, they were included, in fact, because they have high temperature resistance, and the high temperature is the function, so to say. But you're right. Probably the mechanical properties in this case are involved mostly.
Yeah.
So.
Yes.
I mean, actually, they're basically involved probably in all the applications in the end. So of course, the material has to work out in the application also mechanical wise. But you're right. I mean, it's not always an easy line. Like, where does the functional material start and the normal material end, let's say? So it's or a structural material. So if you can elaborate more on this with us, this would be very appreciated. So thanks for the offer. I guess we'll take you up on this.
Thank you.
Yes,
yeah,
thank you.
I think, as you said, Sebastian, there is a gray area sometimes. Because if you think about 316L, it's not probably a functional material in itself, but if it's a porous one with the right porosity, then the porosity is the function.
Because it has a certain biocompatibility.
So in a sense,
yes.
Even iron could be a functional material.
Exactly.
In some occasion. I don't know. Anyone else who wants to comment? I think Jörg Weise is here as well. Maybe he wrote something in the booklet as well. Hello, Jörg.
Hello.
Who is also going to speak in the seminar in a few days, probably.
Okay. We covered the subject of damping structures or damping materials, which maybe is not that much in the focus of the PM industry. But as you maybe know, we at IFAM are working a lot on porous materials. There exist several techniques, metallurgical techniques for producing such structures, and those are also good damping materials. So we see some possibilities for PM in this field. We see some interest, especially because of electromobility. So in the electric vehicles or electric bicycles, sound generation is maybe a larger problem than in normal cars. So it's an interesting field, and we hope that it will increase in the next few years. So,
yes. Thanks.
There's also a comment in the chat from Kenny Alvarez regarding amorphous metals. He says the key is the design of alloys. Yes, I think so. Maybe I can ask Jose Manuel Martin. Are you there, Jose Manuel? He's also one of the organizers of a seminar next week. He was there, so it might be.
Yes,
hello,
Bruno,
Jose.
can you hear me?
Yes, we do.
Okay. Good morning, everyone. Just I was collaborating a little bit on this section of magnetic materials, and well, everything was basically written by Bernd Grief, and just I went through the text of Bernd and did some comments. And well, I think Bernd did a very good work in this session, and with very few words, he wrote a very comprehensive. He gave a very comprehensive description of this family of material. I think also the section of soft magnetic materials is quite well, because the main problematic with these materials at present, I think, is the core loss and their dynamic conditions, and this is very well explained. And perhaps here we could provide more information about the materials that are used to minimize this core loss, and new materials that are emerging. I think that with the topic of electromobility and so on, it is going to be a higher demand of this kind of material, and especially for high frequency applications, AC/DC converters and so on. We work in the range of kilohertz, megahertz, and so on. And here the core loss are going to be very important. So soft magnetic composites, for example, are going to find new applications. And here one of the points is the coating that you are using, where there are developments, but also let's say the magnetic material itself. And very recently we are seeing new developments, as Moritz has commented about the production of bulk soft magnetic materials, which are bulk amorphous materials, right? So perhaps this could be something that we could complete in the future with some examples of applications and the description of these new materials for this section. This is basically what I can comment on that.
Yes, thanks. And see you in the seminar in a few days.
Yes, about the hard materials.
Looking forward. Also, yes, also. Yeah, okay. Any other opinions? Maybe I could ask some people that I know. Mark Dugan, are you there? Have you had the chance to read the booklet talking about magnetic materials, maybe, or others?
Hi.
Hi, Mark.
Yes, I've had a chance to look through it. I've enjoyed looking through that quite a lot. I think it's an excellent first edition. Although I have to say that I have a bad conscience about this, because I was supposed to be contributing more to it, and unfortunately the last year has left me with less free time than I would like to be able to do these things.
Yeah.
So maybe for the second edition.
You're booked.
But I think particularly coming back to what Sebastian was asking about earlier on with chapter 3, I was surprised, but pleasantly surprised, I think, by the depth of chapter 3 as an introduction, as a sort of overview introduction. I think it's a very nice job, and I think that will be useful as a presentation of the sector, not just in the context of functional materials. So I would favor keeping that very much in its current form. I think that's really a valuable resource that they've put together there.
Thanks.
Good.
And I think with time, where we can maybe enrich it a little in terms of case studies, as has been mentioned, and that will be really quite a useful reference guide, I think, to have available. So congratulations, and thanks for all the hard work from those who have been contributing to it.
Right. Thanks, Mark. There is a raised hand. I don't see who is that. Oh, I still see
yeah.
Yoko. Yes, yes.
I have a small comment about chapter 3. That to be shorter in the booklet. So there's something which we can read with another booklet like MEM or AM or general powder processing. We can make it much shorter. However, for example, in the section 3.9, which is only for the functional materials, this must be much longer and can be much more detailed. So this is my opinion. And about the chapter 4 for functional materials, this is very wide range of areas. So nobody is in the specialist of all of them. But this also for the concerning the point from the reader, normally they don't read everything in chapter 4. They read only some chapters, section which is very interested in. So this can be much detailed in the future. So this is only my comments about the future booklet.
So you mean that in the chapter 4 there should be more details on the different kind of topics? So
yes, in the
some mechanical properties, some range of application area.
That can be much more detailed, not too much, but for me the chapter 3 for the general powder PM processing is too long. This is my opinion. And I have a little bit additional comments that it might be interesting if we show some standard which we can approach. For example, for the biomaterials or magnetic materials. So this we can show which standard ISO or STM can be the reference. That might be interesting for the beginner or reader who are interested in some topics.
True.
Yeah.
Thanks.
Okay. Yeah. You're welcome.
Right. We're already officially 12 minutes after the end of the meeting, but we still have the tail in the chat in case. So maybe we could. What do you think? We can probably stop here this webinar and invite everyone to continue discussing if they want in the chat, and maybe even one-to-one. I mean, there you can. It's just like walking in a room with your coffee in your hand and just meet someone and discuss. So it's like getting out of this room as we were in person normally, as we did until last year. We would walk out of the room and maybe stop with the speakers and the ones who have talked during the seminar and asking some more details or just introducing ourselves and trying to make some networking. I don't know if you want to add some final comments, Sebastian and Martin.
Well, just thanks to everyone for joining and participating, and of course all the contributors to the booklet, and especially Martin for the most part of the work, and then also Bruno for pushing us always when it was necessary. So thanks to all of you from my side.
Same for me. I also want to thank you for contribute and for the discussion today, and also for all of the people who contributed to the booklet. And so now we have a basis that we can improve in the next years. So thank you.
Exactly. Differential improvement, incremental.
Incremental, yes. Perhaps sometimes largest.
Or decremental, as someone suggested. Okay, so thanks to all the participants, and as I said, we can continue on the other side if you want, and please keep in touch with EPMA and all the activities. Go and download the booklet if you haven't done it. Tell your colleagues to download it and spread the word. And wait for the HM booklet that is coming later in the year, like Stephen announced, and it will be another good effort, I think. Thank you very much again. Thanks to all the overseas participants, and see you in another occasion. Bye, everyone.
Bye-bye.
Bye-bye.
Bye. Thank you.